In order to start developing a network environment for penetration testing, we want to get a wide variety of different image files for both Windows and Linux operating systems. So for Linux operating systems, we want to go ahead and use the resource distrowatch.com. And basically what this site is a comprehensive list of different Linux distributions that are available. And within each description, you can find either a link where you can directly download the ISO image file or a link where you can find the download file. For Microsoft operating systems, browse to technet.microsoft.com and then select Downloads. Here you'll see that Microsoft makes available a large variety of different software for trial periods of 90 days. If you select See All Evals under any one of these, you can see that there's actually quite a lot to work with. Additionally, you can get a TechNet subscription that you'll have to purchase from Microsoft. And if you purchase this, you get fully licensed versions of all of their software. Not only the latest software, but also software that goes back. If you click operating systems here, you can see that we have everything from MS-DOS all the way up to Windows 8. And under servers, you can see that there's a large variety of different server operating systems also available. Another resource that might be helpful for some is Microsoft DreamSpark, and this can be found at dreamspark.com. And what this is basically a program by Microsoft that provides fully licensed copies of different software for students. If you go down to Download Products and then you click Learn More, you can see a list of some of the products that are available. And as you can see, a bunch of different developer tools are available, but in addition to that, there's a wide variety of different Windows server operating systems that can be downloaded. So by using a combination of different resources, DistroWatch for Linux distributions, and a combination of Microsoft TechNet, free evaluation downloads, and DreamSpark, you can start developing a very reasonably sized library of different operating systems that can be used in your test network. One option for setting up your virtual lab is going to be Oracle VirtualBox. So in order to download that, go ahead and go to www.virtualbox.org. And then go ahead and select the Downloads link. And then select the latest version for x86 and 64 Windows hosts and select Run. Now the installation for this is very straightforward. Just click Next, then Next again, then Yes, and then click Install. Once the installation is completed, select Finish, and that will launch the VirtualBox application. And then to create a new VirtualBox, select New, and then go ahead and type in the name of the new virtual machine. So in this case, we'll do Ubuntu host. You can also select the type of operating system and the specific version of the operating system. Then select Next, and the memory size will actually automatically adjust based on the requirements of the virtual machine you're trying to create and your host system amount of RAM. So just go with the default, select Next, and then create a virtual hard drive now. And then select the hard drive type. We can go ahead and go with the default of VDI. And then selecting dynamically allocated. And that'll automatically adjust the size of the hard drive up to the limit that you specify here. And then go ahead and select Create Hard Drive Now. And there you have your virtual machine. One of the advantages of Oracle VirtualBox over VMware is that you can manage as many virtual machines from this interface as you'd like. Now to start setting up this virtual machine, we'll go ahead and select Settings. And then a bunch of different options here. We'll go ahead and start with Storage. And here we can set our ISO to our IDE controller so that we can boot from it and start the installation process. So we'll choose a virtual disk and then browse to the directory that you have saved all of your different operating system ISOs. And in this case, we'll go ahead and install the Ubuntu 11.10 desktop. Under Network, there's a number of different options. You can select different types of adapters. For our case, network address translation is the best choice. Then also here you can choose different USB devices that you want to push through to the virtual machine. And then select OK. And now that we've set our ISO, we can go ahead and double click on the virtual machine and it will start the installation process. So that is how to install Oracle VirtualBox as one option for setting up your virtual penetration testing lab. To install VMware Player, open up a web browser and then browse to www.vmware.com/products/player. And then select the download button. Once there, you'll see a display of multiple different download options. And if we expand the details on the first one, you can see that the first option is actually the one for Windows 32-bit and 64-bit hosts. So select download and then select run. Once that's started, go ahead and select next. Next again, then check for product updates, help improve VM Player, and then select the desktop icons that you want and click continue. Once the installation is completed, click finish. And then double-click the VMware Player icon to open up the application. As you can see, the user interface for VMware is very similar to what we saw with VirtualBox. However, unlike VirtualBox, with VMware Player, you have to open a separate instance of VMware Player for each virtual machine that you want to run. To start a new virtual machine in VMware Player, select Player, then File, then New Virtual Machine. And as you can see, you can install your virtual machine from either your host optical drive or from an ISO image file. We'll go ahead and select the ISO option and then select Browse. Then browse to the directory that you have your image file saved in, and we'll go ahead and select our Windows 7 image file here, and then select Next. And one of the advantages of VMware is easy install. It actually allows you to enter the product key for any Windows software here, and also enter the username and password that you want to use. In this case, we'll go ahead and bypass that option. And then you can enter the virtual machine name here, and the location where you want the files for the virtual machine stored, then Next. Then you can choose the size of your disk and also to store it on one single file to make it easily manageable or into multiple files. Then once finished, click Finish. And then you can right-click the virtual machine and go to Virtual Machine Settings. And you can see that the settings can be managed very similar to the way they were in Oracle VirtualBox with the allocated RAM to the virtual machine, hard disk, IDE controller, USB drives, etc. So that's how to use VMware Player as an alternative option for setting up your virtual test lab. Now I'm going to demonstrate how to download and install Kali Linux using a VMware environment. Begin by opening your web browser. Then browse to www.kali.org. Then from the main page, select the Downloads option at the top. And from this site, you can either enter your information to receive updates, or you can select No Thanks, just want to download. We'll go ahead and do that. And then select the configuration for your distribution. I'm going to go ahead and go with the default and click Download Kali. And then I'm going to save it to my desktop. Once your download is finished, open up VMware. And then we're going to create a new virtual machine. Select Player, then File, New Virtual Machine, and then select the ISO option, and then Browse. And then browse to the location of your new downloaded Kali Linux ISO. Click Next, select Linux, then Next, then enter your virtual machine name, then Next, select your disk options, and then Finish. Then double-click on your virtual machine to start running. From the main boot menu, select Graphical Install. Then select your language, your location, and your keyboard layout. As you can see, most of the installation process is pretty self-explanatory. Then select a hostname for your system. And we'll leave the domain name blank since I'm not adding it to a domain. And then select a root password for your root account. And then select a time zone for your clock. And then configure your disk options. I'm going to go ahead and go with defaults on these. And then continue. And then yes for write changes to disk. Once the installation process is completed, it'll reboot to this screen. Select the first option. And then you get your login screen. Because the root user won't show up on your login screen, you'll have to select Other, and then enter your username as root. And then use the password that you configured during the installation process. And then click Login. And there you have it, your fully installed Kali Linux distribution for penetration testing. The final step in setting up our lab is to increase the attack surface area. We do this by making different machines within the network as vulnerable as possible. I recommend getting some older operating systems that are unpatched. In this case, I have Windows XP Service Pack 2. You also need to change the configurations of the systems to increase attack surface. So we'll go ahead and go to Control Panel, and then go to Security Center. And as you can see, by default, the firewall and automatic updates are on, so we want to change that. So click Automatic Updates, and then switch that to off. And then Apply and OK. Then select Windows Firewall, and turn that off. Additionally, we want to stop these pesky pop-ups that come up, so we want to click Change the way Security Center alerts me. And then uncheck each one of those. Then go into Internet Options. And we want to set each of these different profiles to custom level, and then set it to the lowest possible security setting. Also go ahead and enable anonymous logon on each one, and then click OK. And you'll do this for each of the different profiles listed at the top. You should also change the configuration of any server machines that you have. So Start, and then go to Administrative Tools, and then Server Manager. Then also we want to add as many roles as possible. By doing this, we also increase the attack surface area by opening new services on the system. Once you've enabled the different roles, go ahead and select Next and go through the installation process for those. Additionally, there's also a number of different features that you want to add. So select Add Features, and then I would recommend at a minimum selecting SNMP services, SMTP server, Telnet client, Telnet server, and TFTP client. Another way to increase the attack surface on your network is to install Metasploitable. So open a web browser and go to www.sourceforge.net. Then search for Metasploitable. And if you click the first link, you can see that what Metasploitable is an intentionally vulnerable Linux machine. And you can use this for carrying out various exploits. Once you've downloaded the ISO file for Metasploitable and installed it on a virtual machine, Open up the virtual machine and you'll get this screen. And then in order to log into the Metasploitable virtual machine, you will use MSF admin for both the login username and password. Then once in, enter ifconfig to find out the IP address for that machine and make note of it. In addition to a number of other vulnerabilities, Metasploitable also has a number of very vulnerable web applications hosted on it. In order to access those, go to one of your other hosts within your virtual network and open a web browser. Then type in the IP address for the Metasploitable VM that you noted earlier. And this is the home page for the Metasploitable web service, and as you can see, there are several different links for locally hosted vulnerable web applications on it. So by using these different methods, you can increase the attack surface of your local area network, allowing you to perform multiple different penetration tests on your network. Prior to ever interacting with the target network, you want to gather as much information as possible from publicly available resources on the web, so as to leave a small digital footprint as possible. So the first place you would want to check is any websites that are made available to the public by the company. Suppose that we're doing a test for Microsoft, then we would want to go to Microsoft.com and see if we can find any information about the hardware or software used by the company, or see if they have any publicly available information about their employees. However, companies are more careful about information security these days, but that hasn't always been the case. So the next place we would want to check is archive.org. This is a collection of archived websites. In the Wayback Machine, enter www.microsoft.com and then click Take Me Back. This will give you a history of the website, in this case dating all the way back to 1996. And you can select any of the linked dates to look at the website exactly as it existed at any time from the first recorded archive all the way up to the present. If the company during any time in its history practiced poor security policies, you may find some revealing information that could be used later in your penetration test. Another website that can be very helpful in gathering information about a company is LinkedIn.com. If you perform an advanced people search by clicking the Advanced tab, then enter the company name, then search for employees associated with a particular industry, I'll select Information Technology and Services, and then click Search. This will enumerate all individuals working in information technology for the Microsoft Corporation. This can be helpful to gather detailed information about employees for the purpose of social engineering attacks, and also by looking at the different roles and functions that they perform, you can often find out detailed information about different hardware or software technologies that are used by the company. Serversniff.net is a website that has a number of different tools that can be used for gathering technical details about a company's network infrastructure. These include different reporting utilities for general information gathering. Under IP tools, there are several different traceroute and ping utilities available. Also, IP info will allow you to gauge how inbound traffic is handled and possibly help you to determine if the target is sitting behind a firewall. Nameserver will allow you to gather publicly available DNS details. WebServer will perform reconnaissance against websites on the target domain. Most of these tools can be executed just by entering a domain name. In this case, we're going to enter Microsoft.com in the robots.txt tool. This tool will list the contents of the robots.txt file on a web server. This is a document that is used by web administrators to request that search engines not spider through specific sites and directories. This could be helpful for finding information that could be potentially sensitive or locating information that a web administrator is trying to hide. I don't have time to go through all the tools that are available on this site, but I highly encourage you look through them and play around with them.
You may be surprised how much information you can gather about your target network without ever interacting with it, and just by using publicly available resources. Some other resources that can be helpful in profiling a target network include geektools.com, networktools.com, and domaintools.com. Google hacking is a term used to refer to any use of the Google search engine in order to passively gather information about a target network within the penetration testing process. In truth, Google hacking is nothing more than effectively using the search engine to query for very specific information. In this video, I'm going to discuss some basic Google hacking techniques. First, I'll discuss some of the advanced operators that can be used within a search. Any operator is performed by entering the operator name, followed by a colon, and then followed by the search term. No spaces are to be included anywhere in the syntax. The first one and most important that we should discuss is the cite operator. To use it, type cite, colon, followed by the domain name. So in this case, we'll try cite:/microsoft.com, and you'll notice that all the results that are populated are only from the Microsoft.com domain. We can try this with another site, say offensivesecurity.com. And once again, that is the source of all the results that are populated. This one can be extremely helpful in a penetration test because it confines all results to a single domain, usually one associated with an organization that you're performing the test for. Another one that's important that you should know is in-title. If we try this with in-title and then the word cheese, you'll notice that the word cheese is included in the title of every single page that's populated in the results. There are a couple similar operators that you should be aware of, such as in_URL. And in this case, the search term is always found within the URL that's returned. Finally, one other similar one is in_text. And this will return only results in which the search term is found within the text of the website. Another important operator that you should be familiar with is the extension operator. To use this, type ext:, followed by any extension type. So we could try like PDF. And then all of the results that are returned are of the PDF document type. Another example would be txt. And then only text documents are returned. We can combine this operator with different search terms as well. For example, if we only wanted to search text documents about war, then we would use extension txt and then the search term. It's also important to understand the effect that special characters can have on your search results. We'll go ahead and enter the search term Blender, and what we get is a combination of two different types of results that are returned. One, your household appliance, and then the other, which is an open source 3D graphic rendering software. So let's say that we wanted to exclude any results about that software. Then we could use the minus sign and then remove a certain term from our results. So we'll do minus software, and then the only results that we get returned is our common household appliances. Finally, quotations are also very helpful for querying for very specific information. If we include the term offensive security within quotations, then it won't just return any site that has the word offensive and the word security somewhere in it, but only sites that have those two words paired together in a phrase. While we're here, we'll go ahead and click on the offensive security site. And the final thing that I want to show you is the Google hacking database. So we'll select projects and then select more information under the Google hacking database. And then select the link for it. And what we have here is a whole collection of different queries that can be entered into Google to gather very helpful information, whether it be footholds to get into a web server, usernames, sensitive directories, web server detection, vulnerable files, vulnerable servers, error messages, juicy information. So as you can see, Google hacking can be very effective for gathering all kinds of information that you possibly wouldn't even expect would be available on the web. Now that we've discussed some basic Google hacking techniques, I'd like to demonstrate how it can be used in the information gathering process. I'm going to show how to use Google to enumerate the subdomains for any given domain. We'll start by defining the domain that we want to search within. So we'll use the cite operator, so site:/Microsoft.com. This will only return content within the Microsoft.com domain. Then we want to use NURL:*Microsoft.com. In this command, the asterisk is used as a wildcard, so this will return any results that have within the URL something.microsoft.com. Finally, we want to remove the obvious www.microsoft.com results. So we'll use -NURL:, and then www.*, so that removes any results that begin with www. And then our result, as you can see, is a list of several different subdomains. We've got technet.microsoft.com, support.microsoft.com, and windows.microsoft.com. If you continue to browse through the results of this query, you'll probably notice that a number of the results will come from these three subdomains. So to continue enumerating without further instances of these same subdomains, we want to eliminate them from the results. So to do this, we'll use -NURL and :support*, so that'll remove any results that begin with the word support. Then NURL: technet*, and then NURL: Windows*. So we'll do that for each of our different subdomains so that we can continue to enumerate new results. And then, as you can see, we get more: msdn.microsoft.com, social.msdn.microsoft.com, research.microsoft.com, office.microsoft.com. So then we want to continue the same process and remove these in the same way that we had removed the earlier ones. So -NURL, and then each of our different subdomains that we just enumerated. So MSDN, social, research, and office. So far, we have quickly enumerated over 10 subdomains just by using Google queries. As you can see, by continuing this process and consistently making note of the results, you can quickly develop a comprehensive list of subdomains for any given domain name. This is just one example of how Google hacking can be used for the information gathering process. An excellent resource that I would recommend for learning other Google hacking techniques is a PDF document by Johnny Long. You can find this document easy enough by using Google hacking technique of specifying the file extension. So we'll use ext:/PDF, and then specify our search terms, Johnny Long Google hacking. And then it's our first result that populates. And we'll select this. And what this is just a massive tutorial of different techniques that can be used for Google hacking within the penetration testing process. Now we're going to discuss some of the tools that can be used in Kali for automating the passive information gathering process against a target domain. It is important to note that unlike Backtrack, Kali's predecessor, all of the tools in Kali can be executed from any location in the file system. So we'll start by opening up a shell, and then from any directory, we'll go ahead and we're going to look at the tool Dimitri. So to look at the various uses and proper syntax of Dimitri, we'll just enter the word Dimitri, once again, from any location in the file system. As you can see, there's a lot of different options that you can use for information gathering against a target domain. For example, we'll perform some reconnaissance against hackthisSite.org. So to run this command, we'll enter Dimitri, and then -I to gather the whois information, N to get the netcraft information, S to search for possible subdomains, and then E to enumerate any email addresses that can be located within the target domain. And then we want to specify our output with -O, and then the name of the output file, so we'll use hackthisSite.txt, and then specify the domain that you want to perform the reconnaissance against. So we'll do www.hackthisSite.org. and it immediately starts gathering information. Once completed, you can use ls to list the contents of the current directory, and you'll see that your output file was placed in the same directory that you ran the command from. We can then read that output file with the cat command, so we'll use cat hackthisite.txt. And information in this file includes the whois information, a number of different host names and corresponding IP addresses. And it also attempted to locate email addresses, but in this case failed to do so. Another helpful tool for automating passive information gathering is goofile. This is a very simple file enumeration tool that will search a domain for a specific file type using the Google search engine. So, for example, we'll use goofile, then -d to specify the domain, and we'll specify our ftp.microsoft.com site, and then -f to specify the file type that we want to search for, and then we can use any file extension, so we'll go ahead and try txt. And that will return any text files located within that ftp.microsoft.com site. So that is how to use Dimitri to perform general information gathering against a target and goofile to perform file enumeration on a targeted domain. Maltego is one of the most comprehensive information gathering tools in Kali. In order to access it, just type Maltego from the command line. Maltego works by using whatever information the user has about a target network as a foothold to gather more information about the target. It uses a technique called transforms to gather new information using information that is already available. Start by selecting New up in the top left corner. And different types of information gathering are separated into different palettes to include devices, infrastructure, locations, pen testing, personal, and social network. Devices, infrastructure, and locations can be helpful for gathering information about a target company or organization. Personal and social network can be used for gathering information on specific individuals within an organization for social engineering purposes. And penetration testing integrates several pen testing tools into the Maltego platform. We're going to start with infrastructure. So we'll go ahead and expand that and then drag DNS name over to the center screen. By default, it loads the manufacturer server, alpine.panterva.com. We can change this name and perform information gathering on any target by entering the property view. But for now, we'll just go ahead and go with the manufacturer's server to perform the demonstration. So we'll start by resolving that server back to the parent domain. So right-click it and then run transform, then convert to domain, and then to domain. And it immediately resolves the Alpine server back to paterva.com. And then we can use that to start gathering information about that domain. So we'll start with gathering MX servers or mail servers, and then DNS from domain, and we'll gather name servers. Then we'll gather different hosts by using common domain names. And as you can see, within a few seconds, we've already gathered a whole bunch of information about this domain and enumerated numerous different systems to include mail servers, name servers, and different host systems. There's still a lot of information that can be gathered from the parent domain. But in addition to running transforms on it, we can also run transforms on all of the objects that were created as a result of previous inquiries. This allows us to use a point-and-click approach to continue to yield more and more useful information. Here we've just gathered the IP address of a particular host that was previously collected. We can also organize this information with different views that allow us to see different relations of different systems to each other. We can also select from main view, bubble view, or entity list, which will give us information about each of the different objects that have been discovered. So that's just one example of how you can use Maltego to gather information for penetration testing with Kali. In Kali, there are both passive and active discovery tools that operate at layers 2, 3, and 4 of the OSI model. In this video, we're going to discuss layer 2 discovery tools. And the first one that we are going to discuss is called rping. Rping uses address resolution broadcast packets to ping systems on the local area network. It's faster than the traditional ICMP ping, but cannot be used for remote hosts, only hosts on your local network. To perform a standard layer 2 ping, open a shell and enter the basic command from any directory. The command is rping, followed by the host address that you want to perform the ping on. This will continue to send packets until you stop it using Control-C. We can also specify the number of packets that we want to send by using the -C switch. So enter the same command again, followed by -C for count, and then specify the number of packets, so we'll just send 1. To better understand what's going on here, we'll open up Wireshark from a separate shell. Wireshark is a packet analyzer that will allow us to see in detail the traffic that is being sent back and forth between your Kali system and the target that you are attempting to ping. So in the filter, we'll enter eth.type == 0x0806. This hexadecimal value will allow us to filter out only ARP packets. Then we'll start sniffing and run the command again. Then we'll look back at Wireshark, and what is taking place here may look intimidating, but it's actually fairly simple. We are broadcasting a layer 2 ARP request, asking who has the pinged layer 3 IP address, and then we're receiving a reply back from that system, if it's alive, indicating its physical location or its layer 2 address. You can also perform layer 2 discovery using nmap. Use the command nmap-pr to specify ARP packets, then -sn to disable the port scan, and then enter the range of IPs that you want to perform the discovery on. And we almost immediately receive a response that 9 hosts are up. So we'll open up Wireshark once again to see what's going on in the background, and we'll start a new session. And then we'll run the command one more time. By analyzing this traffic in Wireshark, you will see that the local area network is flooded with ARP requests for each IP address within the range, and then any hosts that actually are alive are replying with their MAC address associated with the IP address that was pinged. Finally, NetDiscover is another good tool for layer 2 discovery. To perform a basic ARP scan, use the command netdiscover-r followed by the IP range using the /24 notation. And this will scan the entire Class C range. This is helpful because it actually includes a little bit more information to include IP address, MAC address, and MAC vendor. We can also perform this scan passively to only listen for ARP broadcasts from other systems using the -P switch. This will take longer, but will allow you to discover hosts without ever interacting with them. So those are some tools that can be used to perform layer 2 discovery both actively and passively. The most common used discovery methods operate at layer 3. The first tool that I'm going to discuss is fping. Use fping-h to see the use and various syntax of this tool. Then to perform the basic command, use fping-a to list hosts that are currently alive, and then -c and specify the number of packets that you want sent. And then enter the target address. This will return the number of packets transmitted, packets received, and % lost, and also a minimum, maximum, and average amount of time required between initial transmission and response. Next, we are going to ping a range of IP addresses by using the -g switch to generate a list. So we'll enter fping-a, -c, and then specify just one packet this time, and then -g, and then to specify the range of IP addresses, we'll enter the first IP address, followed by a space, and then followed by the last IP address in the range. And fping will automatically generate the list of IPs between those two addresses and attempt to ping every single host in that range. And it will then return the same results for each of those different hosts. An alternative option is to use a file list of IP addresses to test against. You can use ls to enter the contents of the current directory, and here I have a iplist.txt text file with a list of IP addresses. I can then use this with fping using the command fping -f for file, and then enter the location of the file, so root and then iplist.txt. And as you can see, each of those different hosts are currently alive. Another tool is hping3. Use hping3-h to see the various uses and syntax of this tool. Now, this tool has several different modes. What we want to focus on is ICMP mode, and we also want to focus on the IP and ICMP options. So to scan a single host, we want to use the command hping3-1 for ICMP mode, and then specify the target IP address. This will continue to ping until you stop it with Control-C. You can also specify the number of packets that you want to send with the -C switch. And in this case, we only sent one packet. There was another tool in Backtrack, not present in Kali, called genlist that would create a basic list of IP addresses for live hosts. Personally, I like this output best. Fortunately, this is easy to recreate just using a basic bash shell script. So we'll use the basic ping command. Ping any given host, then -C and 1. And then we'll ping a host that isn't alive. Notice that the phrase bytes from is a unique phrase that is only present in cases in which a reply was received, and also contains on that same line the IP address of the live host. So to script this out, let's use the grep command to extract just that line in cases in which a reply is received. So we'll use the same command and then grep bytes from, and then it only returns that line. As you can see, nothing is returned if we do the same command against a host that isn't currently alive. So then we want to cut out just the IP address from that output. So we'll use the cut function and then -D to specify a delimiter, and then we'll use a space as our delimiter, and then we'll go to the fourth field. We determine this by looking at each of the fields separated by spaces, so that's 2, 3, and then the IP address is on the fourth field. Okay, then we want to cut the colon off of the end of that, so we'll use the same command again and then pipe it over, and then use cut one more time and then specify the delimiter as colon. And then we want to specify the first field. And then we get the output of just the IP address. So then what we need to do is we need to create a shell script that will perform this exact same function, but in a loop for each of the different IPs. Now I've already done this. If we enter my pinger.sh shell script, you can see that what this does is for each address in a sequence of 1 to 254, so my entire class C range, we're going to perform that exact same command, a ping of one packet, then grep out the bytes from unique phrase, and then cut out only the IP address and then cut the colon off the end of it. And this will provide us a list of all of the IP addresses within that range. And there you have it, a simple script that will ping your entire Class C range and return the IP addresses for you. So those are some various ways that you can perform Layer 3 discovery in Kali Linux. So we're going to go more in depth with the use of Nmap for discovery at Layer 3 and Layer 4. First, we are going to filter ICMP traffic on Wireshark to see what is being sent. So we'll enter the filter ICMP, and then select our interface and start sniffing. And then we're going to run an ICMP ping request with Nmap on a range of remote IP addresses on the web. So we'll use Nmap, then -SN to suppress the port scan, then -PE to specify the ping scan, and then enter the range of IP addresses. In Wireshark, we see a complete series of ICMP ping requests and replies from live hosts. Now we'll stop that session in Wireshark and create a new session. And then we'll use the exact same command, but this time with a private range of IP addresses on our local area network. So we'll run that command and then change the range of IP addresses. And as you can see, we almost immediately get results of 9 hosts that are up. However, Wireshark indicates that absolutely no ICMP traffic was passed. So why is this? Well, let's change our ICMP filter in Wireshark to a filter that only allows us to display ARP packets. So we'll use eth.type == then 0x0806. You'll notice that even though we specified an ICMP ping scan in Nmap, it will first attempt to locate them using layer 2 because that's a quicker response. So when using a ping scan in Nmap, the scan is actually adaptive and will use the type of scan that provides the quickest results. Layer 4 discovery can be useful if systems cannot be discovered at layer 2 because they aren't on your local area network, or can't be discovered at layer 3 because they are configured to not reply to ICMP traffic. A scan that we can perform to discover systems at layer 4 is a UDP scan. So let us adjust our Wireshark filter accordingly. Change the filter to UDP, &&, then IP.src for IP source address, and then ==, and then specify the IP address of our Kali system. And then we already have data there, so we'll go ahead and start a new session. And then to perform our UDP discovery scan, we'll use nmap-sn to disable the port scan, and then -pu and specify the UDP port that we want to scan, so port 53, and then the IP address range that we want to perform that scan on. The result is a list of DNS server status requests. Now if we change that filter to only show traffic that's being sent to our system with IP destination address and our home address, then you'll see a series of both automated host unreachable responses, or in the case of live hosts, a standard DNS query response. DNS is a good option for a UDP discovery scan because it's a commonly used UDP port. Another option for layer 4 discovery is a TCP ACK ping. To do this, we'll change our filter in Wireshark to TCP, then &&, then IP source address is equal to our Kali IP address. And then to perform the ACK ping discovery, use nmap, then -sn, and then the IP range that we want to perform the discovery on, and then -PA, and then the TCP port that we want to perform the ping on, the ACK ping on, and we'll use port 80, since it is also a commonly used TCP port. By reviewing the Wireshark data, you'll see that a series of unsolicited ACK replies were sent to each of the hosts in the range. If you look at the replies then sent to our system by changing it to the IP destination address, you'll see that all the live hosts that have services running on port 80 will return an RST packet to reset the connection because the ACK packet sent to them was sent out of context. This is an effective way to trick a machine into indicating that it is alive at the target IP address. So those are some various ways that you can use Nmap to perform discovery at both layer 3 and layer 4. Scapy is a very powerful object-oriented scripting tool in Kali. In order to access Scapy, enter the term Scapy at the command line. The first object that we're going to look at is IP. So enter IP in capital letters, and then open and close parentheses. And then what we want to do is assign this object to a variable. So we'll do IP in lowercase, and then the IP object once again. And then use IP.display, and then open and close parentheses to see the different characteristics of that object. The object is already built with predefined configurations for each of the different characteristics listed here. We can change those configurations by using the variable .characteristic and set it equal to a new value. So IP.dst or destination, and then set it equal to an IP address of a Windows system that I have in my lab. Then I'll use IP.display once again to verify that the changes were made to that characteristic. And as you can see, this will update both the destination as defined and also the source address to our Kali IP address. Next, we want to create an ICMP object and assign it to the variable ping. So we'll use ping equals ICMP, open and close parentheses, and then ping.display to see the characteristics of that layer. And as you can see, by default, it's an echo request. So we'll then send the packet with Windows equals SR1, which is send and receive one packet, and then IP over ping. We'll then receive the reply, and we can review the results of that reply with windows.display. And as you can see, the result is an ICMP echo reply. And also, please take note of the TTL, or time to live value, of 128. Now let's try the exact same process, but this time we will send a ping packet and receive the response from a Linux machine that I have in my lab. So we'll use ip.dst and set the destination IP address to the IP address of our Linux machine. And then we'll do Linux equals, and then send and receive, and IP over ping. And then we'll do linux.display to display the received packet, and once again an ICMP echo reply. But this time, notice that the TTL value is not 128, but instead 64. This is one of the common distinctions between most Linux and Windows operating systems, is that Windows starts the TTL value at 128 and Linux starts at 64. And for each hop required to get to the destination, the initial value is decremented by 1. This can be a very simple way of fingerprinting operating systems, or at least to distinguish between Windows and Linux hosts. So we'll exit out of Scapy, and one of the great things about Scapy is that it can be used or imported into Python for scripting purposes. I've actually already created a very basic Python script that tests to see if the operating system is Linux or Windows based. So we'll look at this script, and basically all it does is import the Scapy module, and then takes input from the user regarding the IP address that you want to test, and then it creates the IP and the ICMP packet layers, and then if the TTL value is less than 65, it defines it as Linux, otherwise it defines it as Windows, and then prints the result. So we can run this real quick against each of our different systems. First, we'll go ahead and do a chmod 777 in order to change the Python script to an executable, and then // and the Python script to execute it. And then we'll enter the IP address of our Windows host. And it immediately returns the result that the operating system is Windows. We can also try the exact same thing with our Linux IP address. So this is a very simple and crude example of how operating system fingerprinting can take place, and also an example of how you can use Scapy within a scripting environment. So in the next video, we'll go ahead and look at some more advanced operating system fingerprinting tools in Kali. Our final step in system discovery is attempting to identify the operating system that is running on the hosts. One tool that can be helpful in passively identifying operating systems is POF. So use the command p0f-h to see the various uses and syntax of this tool. Then for a basic discovery, use p0f-i followed by the interface that you want to perform the operating system discovery on. So in this case, we'll use eth0. As soon as you launch the command, it starts analyzing the traffic on the wire to look for signatures that might identify a specific operating system. This can be especially effective if you have created a man-in-the-middle scenario between a host and the gateway, but you don't want any more interaction between your system and the target system. We'll discuss man-in-the-middle in greater detail in a later video. Unfortunately, in most cases, your screen is going to be flooded with a lot of unknown signatures. So to filter out those unknown signatures and focus exclusively on the helpful signatures, use the command p0f-i followed by the interface, and then -u to eliminate the unknown signatures. Using this approach, you will get fewer results, but the results that you do get will be much more reliable in fingerprinting the operating system. A more active tool in identifying operating systems is xprobe2. Enter the command xprobe2-h to see the uses of the tool. Then to perform a basic OS identification, use xprobe2 followed by the IP address of the target system. Once completed, it will return a best guess listed under primary guess, and then list other possibilities under other guesses. It also includes a guess probability for each guess listed. If you do the math, you will probably realize that the guess probabilities are not relative to one another, as you would quickly end up with way more than 100%. Instead, this is an indication of the percentage of the signatures associated with that specific operating system that were discovered. However, because these signatures aren't always unique, this could result in multiple guesses with a high guess probability. Nmap also has a function that can be used to identify operating systems on target hosts. Enter the command nmap followed by the IP address or IP range that you want to perform OS identification on, and then -O for operating system identification. This will return results that are very similar to what we saw with Xprobe, where it will either positively identify the operating system with a 100% confidence rating, or when less confident, it will give its best guess, and in some cases, will indicate that too many fingerprints match the host to give specific OS details. So those are just a few ways that you can perform both passive and active OS identification on a system.
Nmap is one of the most commonly used and extremely effective command line tools used for port scanning and service enumeration. To see the various uses of Nmap scanning, type Nmap into the command line. To perform a TCP port scan of a single IP address, type Nmap, then followed by the IP address that you want to scan. And then it will report back with the ports that are currently open on that system. To perform a scan on a network range by entering the network address and then specify the range size by a slash and then the number of network address bits. In this case, we're going to do a /24 class C address range. And then it will begin to return all the ports that are open on each of the systems within that range. Additionally, you can also perform a scan on a sequential series of addresses by using a dash. So in this case, we'll just do the last 128 addresses by doing 128-255. To scan for particular TCP ports, you can specify those ports with a -P. Followed by the ports that you want to scan. So in this case, we'll do 21 and 23. And then it will only scan those ports and return the results. You can also scan for a range of different ports by doing -P, and then if we say we want to scan the first 100 ports, we can do 1 through 100. You can use a TCP ACK scan to determine if any ports are filtered by a firewall. You can do this by doing a -lowercase s, uppercase A, and then the address that you want to scan. And then it returns the results showing what ports, if any, are filtered. You can also scan for UDP services with a UDP scan with lowercase s, uppercase U. Now, because UDP isn't connection-oriented, this can take significantly longer than a TCP scan to perform, so we'll go ahead and cancel this one out. But if you want to look for particular UDP services, you can also perform a UDP scan on particular UDP ports. So using the same command, but this time -P, and then the UDP port you want to scan, so we'll do 53 for DNS. And then it returns the results on that. By default, Nmap uses SYN scans or half-open scans, but depending on the security settings of your target systems, you may have more success with other TCP flag scans, to include full connection scans, null scans, fin scans, Christmas tree scans, FINAC scans, or ACK scans. So those are just a few ways that you can use Nmap for port scanning and service enumeration.
An excellent tool for learning to use Nmap is its graphical interface counterpart, ZenMap. This can also be a very helpful tool in performing more visual analysis of the target network. But unlike Kali's predecessor Backtrack, ZenMap does not come preloaded into the Kali environment. However, because ZenMap is available in the repository, the install is very easy to perform. Just enter the command apt-get install ZenMap. Once the installation is completed, you can now open ZenMap at any time by just entering the command ZenMap into your shell. You can enter any nmap command in the command bar at the top of the screen. The nmap output tab shows the same output that you would get from nmap command line. But upon completion, it organizes the discovered hosts on the left side of the screen. If you click the drop-down on the profile from the top right of the screen, you can see a number of pre-configured scan options that you can use in ZenMap. In this case, instead of performing the basic TCP port scan, we'll perform an intent scan on the same hosts. Unlike the basic port scan, the intent scan makes more of an effort to fingerprint the operating systems. Notice how the graphical representations for these systems changed on the left side of the screen. You can click any host on the left side of the screen to see the services on that particular system. You can also organize this data by service and see each system that has a particular service available. If you click the Topology tab at the top of the screen, you will see a visual representation of the network topology. You can also click any host in the topology and make the view relative to that host's location in the network. This also indicates what hosts may have filtered ports by the use of a lock icon. You can click the Host Details tab to see information on any individual discovered host. You can also see a history of your scans by selecting the Scans tab. You can also create new profiles by going up to Profile at the top and then selecting New Profile or Command. In this case, we'll go ahead and create a Stealth Scan profile. And as you configure the options in here, it'll automatically generate the command to perform the nmap scan. We'll start by entering our targets. In this case, we'll just perform a scan on one host. And we'll use a timing template of Sneaky. And since we're performing a stealth scan, we don't want to ping prior to performing the scan. And then we'll select a few given ports. Notice how at the top it's generating the command as we type in this information. So we'll scan port 80, 21, and 23. And then we'll use decoys. And we'll use 5 random addresses. And then fragment the packets so that it's not detected by any kind of intrusion detection system, and then we'll save the changes. And then select the scan now up at the top at Profile and click Scan. And because this is a stealth scan, it'll take a little bit longer than a normal TCP scan to run, but in the end it'll output the same results that you would get from a regular nmap scan. So that's some basic uses of the graphic user interface ZenMap. Nmap is already one of the most impressive programs available in Kali. However, combining it with scripting can make it even more powerful. There are several different ways that Nmap can be used in conjunction with scripting. The most obvious of these is the Nmap scripting engine. Nmap not only supports the capability of running scripts, but it also has its own scripting engine that can be used to create new scripts or modify existing scripts that take full advantage of its capabilities. To view some of these pre-existing scripts, use change directory and go to the user/share/nmap/scripts directory. Then use ls to list the contents. And as you can see, there are a lot of different scripts already available in Kali. We can read any one of these using the cat command. So we'll use cat and then a fairly simple script relative to some of them in here, ftp-anon.nse. If you scroll to the top on any of these scripts, you can find a description of what it does, an example of the output, and any special requirements in syntax. Since there are no special requirements for running this script, we'll go ahead and run the standard nmap script command. So we'll use nmap --script, then the name of the script, so in this case ftp-anon, then the IP address of the target system that we want to run the script against, and then the port. So in this case we'll use port 21 for FTP. The script then runs, and unlike our usual nmap output, which would just identify the open port and service, we also now are told that FTP anonymous logon is allowed. If you would like to learn more about using the nmap scripting engine, I recommend you go to nmap.org/book/nse.html. Additionally, nmap has several output options that are helpful in other scripting languages, to include shell scripting and higher level languages such as Python, Perl, and Ruby. If you enter nmap at the command line, you can see the different output options. XML is a good option if you want to perform output file analysis using the parsing capabilities of any of the previously listed languages. There's also a greppable format, which would make it easy to write file handling scripts with bash script. To demonstrate how this could work, I'll do a basic scan of my network and then use the greppable output format. So -O capital G for output greppable, and then the name of the output file. Then use ls to list the contents of the directory, and we can now see our output.txt. So we'll use cat to read that text file real quick. And what we have here is a series of formatted one-liners that can easily be manipulated using grep. For example, I can quickly check what hosts are alive by grepping for the word up. It would also be easy to write a script to find out what hosts were running a particular service. For example, I'll use grep and then a unique phrase in the output to a specific service, so 22/open, and then the file that we want to perform that grep analysis on. Now I know this looks pretty messy, but we could easily change this by piping it over and then using the cut function in order to pull out just the IP addresses. So we'll use cut and then specify the delimiter of a colon, and then the second field behind the colon, so -F and then 2. And then we'll pipe that over one more time to eliminate everything after the IP addresses. So cut and then specify the delimiter, and then use space as our delimiter, and then a field of 2, and there you have it. Just a single command that can be used to pull the IP addresses for systems that are running a particular service. So you can see how this could easily be integrated into a script to perform subsequent actions to be performed based on those results. So those are a few examples of how scripting can be used in conjunction with nmap to create some very powerful security tools. Zombie scanning is a way of performing a port scan against a target system without that system ever having any record of your interaction with it. To do this, we first need to locate a system on the network with incremental IP-ID sequencing. Some systems are configured to increment the IP identification number of its packets by 1 for each packet sent. A zombie scan takes advantage of the predictability of this sequence. First, we'll use an nmap script to attempt to locate a good zombie system. So to do this, enter nmap, then --script, then the name of the script, so in this case IP ID SEQ, and then the IP range that you want to perform the scan against. Once the results are returned, it will show you the IP sequencing status for each system that was scanned. And here we have a system 199.132 that shows that the IP ID sequencing is incremental. So once you've located a system with incremental IP ID sequencing, you can attempt to perform your zombie scan against any other system on the network. Prior to doing this, I'll discuss how this technique works. Take a look at this diagram. This is the sequence of events that take place for each port that is scanned using the zombie scan. First, we send a SYNAC packet to our zombie to record the IP ID of the RST packet that we receive in response. Now we have a sequence number that we can start from. Then we send a spoofed SYN packet using the IP address of the zombie system to the victim that we are performing the zombie scan against. If the port is open on the target system, then that target system will reply to the zombie system with a SYNAC packet. Because the zombie system didn't actually send the initial SYN packet, which was spoofed by our system, it then replies with an RST packet to reset the connection. This causes the IP ID value of the zombie system to increase by 1, but only if the port of the victim system is open. Finally, we send another SYNAC packet to the zombie and record the IP ID value one more time. If the value has incremented by 2, then it means that the system received a reply from the victim. And if it is only incremented by 1, no reply was received. So let's give this a shot. To perform the zombie scan, use nmap, then dash lowercase s, uppercase I to specify a zombie scan. Then we want to enter the IP address of our incremental IP ID sequence system, or our zombie system. And then dash capital P, lowercase n to prevent an initial ping of the target system. And then the IP address of the target system that we want to perform the zombie scan against. As you can see, we have now successfully enumerated all open ports on the target system. However, the victim machine's records would only indicate that it was scanned by the zombie system and have no record of interaction with our Kali system. So that is how to perform a stealth zombie scan using nmap. There are a number of different tools in Kali that can be used to verify the service running on any given port. The first one I want to discuss is netcat. Use nc-h to see the different uses of netcat. Netcat is an extremely powerful tool that can be used to communicate using TCP and UDP connections. By using netcat to connect to TCP services running on a remote system, the systems will often reply with an automatically pre-configured response called a banner. This banner will sometimes contain useful information that can be helpful in identifying the service running on that port. Now first, I'll run a port scan on our Metasploitable machine to see what ports are currently open. Then using some of those different ports, we'll go ahead and try to connect with netcat and perform banner grabbing. So to do this, we'll enter nc-v for verbose, and then enter the target IP address and then the port number that you want to attempt the banner grab on. So we'll start with port 21. And as you can see, that then returns confirmation that the FTP service is running on port 21 and also identifies the version running on that port. Next, let's try the same command, but this time on port 22. And in this case, we get the same thing, the version of SSH that's currently running on this port, and also operating system information about the host system that's running the service. Same thing with port 25. And here we get similar information, in this case even to include the fully qualified domain name. As you can see, banner grabbing with netcat will often yield very useful information to include the service running, the software that's providing that service, to include version type, and sometimes even host operating system information. This can be extremely helpful later when searching for vulnerabilities on the system.
Dimitri was a tool that we had previously introduced for host discovery, but it can also be used to identify services. If we enter Dimitri into the command line to look at the uses of the tool, you can see that there's also a -P option to perform a port scan, and a -B option to perform a banner grab on any of the ports that are scanned. So if we use the command Dimitri-PB, and then specify our target system, the result is a list of ports that are currently open on that system and any interactive banners that it can grab from the services running on those ports. AMAP is another tool that can be used to fingerprint services. You can enter AMAP into the command line to see the various uses of this tool. And before running it, we'll run a real quick nmap scan to verify the ports that are currently open on our target system. And suppose that you want to verify that the service running on a particular port is actually the native service. We can run AMAP, then -BQV, which is banner grabbing in verbose mode, then specify our target system, and then specify the port that you want to verify the service running on. So in this case, we'll do port 23. And what it does is it matches the banner that it grabs up against a list of signatures in order to, in this case, verify that the service running on port 23 is in fact Telnet. So those are some tools that can be used in Kali in order to identify services running on a remote system. Metasploit has a number of auxiliary modules that can be used to scan target systems for unique vulnerabilities. To access the Metasploit framework, type MSF console from the command line. Then we'll use the search command to look for various auxiliary scanners. So we'll enter search scanner. Here we have an X11 scanner that scans to identify if the X11 service can be accessed with no authentication. Now we know from an earlier scan of our Metasploitable system that the X11 service is running on it. To verify this, we'll do a real quick nmap scan against port 6000. So we'll enter nmap-p, specify the port 6000, and then the IP address. Now that we've verified that the X11 service is running on port 6000 of our Metasploitable machine, we'll copy the path for the auxiliary scanner. Then we'll use the use command to access the module. Then we'll enter show options to see the different configurations for the scanner. And then we want to set our host or remote host to the IP address of our target system. Then show options once again to verify that the change was made. And as you can see, the remote host IP address has been updated. And then use run to execute the auxiliary scanner. Now in this case, our first test failed with an access denied. So we have verified that that vulnerability does not exist on the system. Now we'll search for vulnerabilities associated with FTP. So here we'll grab the auxiliary FTP anonymous checker, and this will check to see if anonymous access can be granted to the FTP service. We'll enter the use command followed by the path of the auxiliary scanner. And then show options to see the different configurations. And once again, we need to configure the R host. So we'll use set remote host, and then we'll specify the IP address of both our Metasploitable machine, separated by a comma, and then the IP address of our XP machine. Both of these systems are running the FTP service. Then show options again, and here we can verify that the remote host was updated. And then run. The results indicate that not only is anonymous access available on both of these FTP services, but it also identifies the FTP service running on each. So those are just a few examples of how you can use Metasploit auxiliary modules
to identify vulnerabilities on a target system. Using automated vulnerability scanners is the quickest way to discover potentially exploitable vulnerabilities on a target system and can drastically increase the speed of a penetration test. There are several different vulnerability scanners that can be used in Kali to include OpenVAS, Nexpose, and Nessus. The functionality and capabilities of all these scanners are very similar. Once you understand how one of them works, it's not difficult to learn how to use the others. To address the use of vulnerability scanners, I will be discussing the use of Nessus through the course of the next several videos. First, let's go through the installation process. So start by opening up your web browser, and then browse to www.tenable.com. Tenable is the company that develops Nessus. Then select Products at the top, and then select Nessus Vulnerability Scanner. Then select the download option on the right side of the screen. Agree to the licensing agreement. Then select Linux for your operating system. And then specifically, the package that we want to download is Ubuntu 10.10 i386. So select that, and then save the file, and I'll go ahead and save it to my desktop. Once downloaded, you should see the package on your desktop. Then go ahead and open up a terminal. Then enter ls to list the contents of the directory. And then we'll change the directory to our desktop. And then list the contents, and you should see your package. So to unpack and install the Nessus package, use dpkg-i, and then the name of the package. Once completed, you need to start the Nessus service. It actually indicates what the command is to perform this action. So then we just need to enter that command. So /etc/initd/nessusd start. And then once the service has started, we can go to our web interface for Nessus. So copy the address listed on this second bullet point. Now this may be different for you depending on the name of your local system. So we'll open up a web browser and then enter that address in the URL bar. And you'll probably get a security exception since you don't have a registered certificate for your Kali machine. So just confirm the security exception. And then select Get Started, and then create an administrator account for your Nessus service. So enter a login name and a password. Then select Next. And you will have to register with Tenable in order to continue to get your plugin feed. And this plugin feed is required in order to use the Nessus scanner. So in order to register, select this nessus.org register address. Then if you're doing this for your personal lab, just select Using Nessus at Home. And this is a free registration code. And then enter your first name, your last name, and your email address. And then agree to the terms of service, and then click Register. Once you've registered, you should receive an email in the provided email address, and then enter your activation code here. And then it should indicate that your registration was successful. Select Download Plugins, and this will take some time. And then once that's done, you will be presented with your login screen. So enter the account and password that you had previously created and click Sign in to continue. And that completes the installation process, and here you have your Nessus Vulnerability Scanner interface. Now we're going to discuss some of the scanning techniques that can be used in Nessus. Now when the Nessus interface starts, it'll start you on the Results tab. Click over to the Scans tab and then select New Scan.
Now the first scan that we're going to perform is going to be a scan on a single host. So we'll create a scan title that reflects that. And then we have a couple different options under scan type, both run now and template. We'll choose the default for now and then discuss the other option later. Under scan policy, we have several different options. Once again, we'll discuss those in more detail later. We'll go ahead and go with the default for now. And then under scan targets, we'll enter the IP address of the system that we want to perform the vulnerability scan against, and then click Create Scan. This will immediately launch the scan against that requested host. You can then click the scan and see the results begin to populate here in the host summary. Okay, now let's switch back over to the Scans tab, and we'll stop this scan by selecting it and then clicking the X icon over on the right side. And now we'll create another scan, this time for multiple hosts. So we'll select New Scan again, and then create a scan title. And then once again, we'll go with the defaults on scan type and scan policy. And here I'm going to demonstrate that you can enter as many IP addresses as you want here, just separated by a carriage return. And it will perform a scan on each of those different IP addresses. So then click Create Scan, and then click on the scan. And you will notice that each of the IP addresses specified will then be scanned and the results will populate here. You can also perform a scan on a sequential list of IP addresses. So we'll use a scan title. And then we'll do our range of IP addresses, so 0-255, to scan that entire range of 256 addresses. Then if you click on it, you'll notice that Nessus automatically discovers each of the different hosts within this range and then begins to perform analysis on them. You can also specify a network range using / notation. So this time we'll specify our entire Class C range using the network IP address and then /24. Another option is to import a list of IP addresses using a text file. This time, instead of listing scan targets here, select Browse, and we'll select our iplist.txt file, and then click Create Scan. This will launch a vulnerability scan against each of the different IP addresses that were listed in that text file. Now we'll discuss the option of creating a scan template. So once again, we'll enter a title, and this time, instead of selecting Run Now, we'll select Template. And we'll do our list of sequential IP addresses here, so 0-255, and then Create Template. Now this time, instead of launching the scan immediately, it creates a template in our Templates tab up at the top. We can then browse back to this at any time to launch this scan as many times as we need to. To do this, go ahead and select the scan, and then select the Options dropdown, and then click Launch Template. Doing this, you can perform as many instances as you need of the configured scan template. Now let's discuss some of the scan policies. Scan policies define the specifics of how Nessus behaves whenever it performs a particular scan. As you can see, there's already 4 pre-configured policies within Nessus. We can look at the details of these by clicking on any one of them. Under General Settings, we have several different options. First, the basic setting type, which includes the name of the policy, the visibility, which can be set to shared so that all users can see it, or just your user account as private, and then a description. There's also several different port scanning options that can be manipulated. Throttling can be configured under Performance. And then several more obscure options under Advanced. If you select Credentials, you'll find that for a more thorough or advanced scan, we can actually enter
Windows credentials for our boxes, or SSH credentials for Linux or network devices. Also, for Kerberos configurations, we can enter credentials for that. And in addition to that, there's also clear text protocol settings. However, I highly recommend not using this because it will send your password clear text over the wire. Now, plugins is usually what distinguishes one policy from another, and this is the different checks that are performed by the scan. Each one of these are different groups of specific checks that can be enabled or disabled. Or you can also enable or disable an entire group of checks. So then we can create a new policy by selecting New Policies. And then we'll do a policy just on Windows systems. And we'll call it Windows Compliance, and we'll set it to where everyone can see it. And then we'll apply SMB credentials to authenticate to those Windows systems for a more thorough scan. And then under our plugins, we'll start with disabling all of the plugins, and then we'll only enable the plugins that are unique to Windows systems. And then click Update. Now to use this new policy, select Scans, and then New Scan. And we'll enter the name for our scan. And this time for the scan policy, we'll select our new created Windows Compliance scan policy. And then I'll only enter the two IP addresses for my two Windows systems, a Windows XP and a Windows 8 system. And then create scan. As each of these scans complete, you can then see the results in the Results tab. And analyzing and understanding the results of the vulnerability scanner is absolutely key to being able to use vulnerability scanning effectively. And that's what we'll discuss in our next video. Now we'll discuss understanding and interpreting the result of your Nessus vulnerability scan. Now under the Results tab, you'll see a list of all of the different scans that have been performed. You can click on any one of these to see the result of that particular scan. Now the vulnerabilities can either be listed out by host or ordered by vulnerability. We'll start with the hosts option, and you can click any host listed here in order to see the vulnerabilities unique to that system. After clicking the system, you'll see a list of all of the vulnerabilities discovered, and they'll be ordered from criticality, all the way from critical and high down to low and informational. You can also click any one of these particular vulnerabilities in order to find more information about that vulnerability. Here you'll find a synopsis of what the vulnerability is, a more detailed description, a solution for remediation, additional information under See Also, plugin information about the plugin that was used in order to discover the vulnerability. Risk information will evaluate the vulnerability based on criticality on a scale of 0 to 10. And then this vulnerability information can be extremely helpful in the exploitation process that we'll talk about later. Notice that it tells us that an exploit is currently available for this vulnerability, and it'll also tell you if it's exploitable with several different exploit frameworks, such as Metasploit, Canvas, and Core Impact. It also provides additional reference information, which generally includes a number of different vulnerability numbering systems. One commonly used one is the CVE. If we click here, we can see more information on the CVE of this particular vulnerability. CVE is the Common Vulnerability Numbering System provided by the United States National Institute of Standards and Technology. One of my personal favorites is the Backtrack ID. If we select the link for this, you'll discover similar information particular to the vulnerability, But even more important than this is the option to select exploit at the top of the screen, which will provide publicly available exploits for the majority of these vulnerabilities discovered. You can then click on the link for any of those exploits, and here we discover a Ruby script that was created for the Metasploit framework in order to exploit this particular vulnerability. Oftentimes with just minor modifications, we can actually use these exploit scripts against a target system. In addition to sorting vulnerabilities by host, we can also sort them out by vulnerability. Here we'll see a list of all of the vulnerabilities discovered throughout the entire scan, and then out to the right side you'll see a number of the amount of instances that were discovered during that scan. So if we select one with multiple instances, we see similar information about the vulnerability, but if we scroll down to the bottom, we can see each of the different affected hosts that were discovered to have that vulnerability in that vulnerability scan. So that is how to evaluate and analyze the results provided by Nessus scanning. The Metasploit framework is an all-in-one exploitation tool that can be used to craft attacks against remote systems by combining pairs of exploits and payloads. To access it, enter the command msf console from the command line. Now I'm going to demonstrate just how easy it is to use Metasploit to exploit a discovered vulnerability. So we'll refer back to our previous section where we discussed how to discover vulnerabilities on a system, and we'll look at the results that we found in our Nessus vulnerability scan. And we'll select our Windows system here, and then I'll select a vulnerability that I know is exploitable within Metasploit. And notice in the description that it does tell us that execution of this exploit will allow you to execute arbitrary code on a remote system. And here in the vulnerability information, it tells you that it is exploitable with Metasploit, and it even gives you the description of the exploit that needs to be used. So we'll copy that description, and then we'll switch back over to our Metasploit framework console, and then we'll search for that description. And there it is. So then we just need to copy the path for that exploit, then enter the command use, followed by that path. Then show options, and configure any options that need to be configured. So we'll set our remote host to the IP address of our target system. Then show options again to verify that that change was made. And then show payloads to see what different payloads we can pair with this exploit. And all of these are just different code that we can execute on the remote system by taking advantage of the exploit that it's paired with. So we'll go ahead and execute a bind TCP shell. So set payload and then paste the path of the payload that you choose. And then show options. And as you can see by the options of the payload, it is going to launch that TCP shell on port 4444. So then use the command exploit to launch the attack against our remote system. And there you have it. We receive an interactive shell on our target system. So now we'll perform a similar attack on a Linux system. So we'll search for the description of the exploit that we want to use. So Java RMI server. And then copy the path of the exploit. Then use, followed by that path. Then show options. And then we'll set our remote host to the target IP address. And then show options again. And as you can see, our remote host address has been updated. So then we'll show payloads. And this time we'll select a meterpreter shell. And then we'll use set payload followed by the path of that payload. And then show options. And once again, this will be opening our shell on port 4444. And then exploit to execute it. And now we have our interactive meterpreter shell on our remote system. So that's the basics of using Metasploit in order to exploit vulnerabilities on target systems. One of the most powerful and versatile payloads available in Metasploit is a Windows meterpreter shell. I'm going to briefly discuss the basic techniques used for navigating a remote Windows system using the meterpreter shell. So we want to start by exploiting our system with a meterpreter payload. Then the first command we're going to talk about is get UID. This will identify the user account from which the shell is running. In this case, we have system access. PS will allow us to enumerate all the processes that are running on the target system. PWD is a command that will allow us to see the directory that the shell is currently running in. We can also search for different files on the file system using search-F and then specifying keywords. So we'll use asterisk as a wildcard and then look for any file that has the word password in it. And we have a couple results returned. So then we can change directory using CD and then specify the directory that we want to change to. Then use PWD to verify that the directory was changed, and then ls to list the contents of the directory. And here we can verify that that passwords.txt file is located within this directory. So then we can actually read the contents of that file with the cat command. So cat followed by the file that you want to read. We can also download that file using the download command. So download followed by the file that you want to download, and then the path that you want to download it to on your local system. You can also edit the file in its current location by using edit, followed by the name of the file. And this will open up an instance of the VIM editor. And then we can save those changes and then verify that the changes were made, once again with the cat command. We can also upload a file to the target system using upload and then the file that we want to upload on our local system and then the directory that we want to upload it to. Right now we'll just upload it to the C directory. And then we'll use CD to change to that directory. Then ls to verify that the file was uploaded to that directory. And here we have it, maliciousvirus.bat. And then we can execute that file using the execute-f command, and then specify the file that we want to execute. And here you can see that a new process was created. We can then clean up by using rm to remove the file from the current location. We can also open up a traditional shell on the remote system by using the shell command. And then we can use any of the traditional commands therein. So those are some of the basics of how to navigate a remote Windows system that has been compromised with a Windows Meterpreter payload. Now we'll discuss some more advanced Meterpreter techniques. So after running our exploit with our Meterpreter payload, we'll use the sniffer function to sniff traffic going to and from a particular interface on the target system. So enter the command use sniffer to load the extension, then the command sniffer_interfaces to list the different interfaces on the target system. Then we can use the command sniffer_start and then specify the number of the interface that we want to start sniffing on. And this will begin capturing traffic on that interface. Once you feel that enough traffic has been captured, use the command sniffer_stop and then the interface number. And then to save that traffic to a file, use sniffer_dump, then the number of the interface, and then the file location that you want to save that captured traffic to. Now we'll discuss how we can capture a screenshot of the user's current activity on the remote system. So we'll start with PS to list the processes that are currently running on the system, and then get PID to list the process that we are currently running our Meterpreter shell on. As of right now, we're currently running it on process ID 992, or servicehost.exe. What we want to do is migrate that service to a process that is actively using the Windows graphic interface. So we'll move it over to process ID 1200 or explorer.exe. So we'll use the migrate command and then 1200, the process ID that we want to migrate it to. Then use the command use espia to load the extension, and then the command screen grab to capture a screenshot of the remote user's activity. And it'll automatically open the screenshot in your web browser, and it will also save a copy to your local system at the specified location. Now, because we can see that the remote user is actively using Internet Explorer, we'll migrate to that process. So we want to migrate to process ID 3536. So once again, the migrate command followed by that process ID number. And what we're going to do is we're going to perform a keylogger attack against that process so that any keys entered in Internet Explorer will be captured by our system. To do this, enter the command keyscan_start. And this will start logging the keys. Then we'll switch over to our target system and simulate the user browsing to their email. So we'll go to www.gmail.com. Then have the user enter the username naivevictim@gmail.com and then a password. Then if we switch back to our Meterpreter shell, we can then use the command keyscan_dump to see the keystrokes that were performed. And as you can see, we have the URL that was browsed to, the email address, and the password for that email address. So those are some more advanced exploitation techniques that can be used in a Meterpreter shell. One of the more exciting features of Kali Linux is the full integration of Rapid7's Metasploit Pro. In order to install Metasploit Pro on your Kali system, enter the traditional Metasploit framework console with the command msf-console. Then from there, type go_pro, and this will start the Metasploit Pro services. Once completed, it will automatically open your web browser to the Metasploit Pro registration interface. Because you don't have a registered certificate, you're likely to get a security warning click I understand the risks, and then confirm the security exception. You'll be brought to a brief initialization screen, and then you'll be brought to the configuration page where you'll be asked to create your login information to include your username and password. You also have the option to enter additional information, or you can just click Create Account. And you will need a Rapid7 license in order to run Metasploit Pro. Fortunately, Rapid7 offers a 7-day trial license. So click Get Product Key. And then from this site, click Get Started. Then enter your information here and click Get Free Trial. After you receive an email with a product key, enter it here and then click Activate License. And there you have it. Metasploit Pro is now fully installed on your Kali system and ready to use for exploitation. Metasploit Pro offers a very simple point-and-click approach to the entire penetration testing process. To get started, we'll click New Project, and then we'll enter a project name and then an IP range for our target network. And then click Create Project. Then the first thing that we want to do is perform a discovery on our target network. So under Discovery, click Scan. Verify the target IP addresses. And then several different advanced options that we can configure. In our case, we'll just go with the default options, and then we'll click Launch Scan. And what this will do is, in the background, it'll perform several different techniques to attempt to identify all live systems on the network, and also identify services and operating systems running on those hosts. Once that's finished, we'll click our project name at the top to return to our dashboard, and then we'll see a graphical display of some of the information that was discovered during that scan. The next thing that we want to do is attempt to identify vulnerabilities on our target network. Rapid7 actually has Nexpose, their vulnerability scanner, fully integrated into Metasploit Pro. We can access it just by clicking this button. However, because we already performed vulnerability scans with Nessus, we'll use the import function. So we'll switch over to our Nessus scanner, and then look at our results, and then click Export Results. Then choose our export format of Nessus, then click Export, and Save File. Then return to Metasploit Pro and click the Import button under Discovery. Then click Browse and choose your Nessus export file. Then click Import Data. Once completed, return once again to your dashboard. And now we're ready to begin exploitation. So under the penetration box, you have options for either brute forcing different services on the network, or you can choose exploit. We'll click the exploit button. And here we can perform exploitation against multiple targets at one time. However, for the simplicity of this demonstration, I'll restrict it to just one target. We can also define the minimum reliability rating. Now, reliability rating is basically going to specify to what extent the exploit is safe to run on a production system and indicate whether it's likely to fail or crash the target system or applications running on it. Once we've set that, we can click Exploit to start. And Metasploit Pro will then attempt to run any exploits that it has available for the target system. Here we see that exploitation of our target was successful, and we now have 2 sessions opened. We can access those sessions by clicking Sessions at the top of the screen. And here we now have both a interpreter and a standard shell on our target system. If we click that session, we can see several different available actions for us. We'll start by collecting system data.
To collect our system data, we'll select our active sessions and then click the button at the bottom. And this will begin to gather all kinds of information from the target system to include password files, sensitive files, and cryptography keys, and all kinds of other information. If we click back on our session, we can see that that information has now been populated in the stored data and files. We can also click Access File System, and we can navigate through the entire file system of the target. We can also click on any directory to browse through those directories and subdirectories. If we return to our session once again, we can also launch a command shell against the target system. We can then interact with the target system. We'll use change directory and change it to the root directory, and then ls to verify that we do have interaction with the target system. So as you can see, Metasploit Pro is a very powerful automated tool that can be used to streamline your entire penetration testing process. While Metasploit is an extremely powerful exploitation tool, you don't want it to become a crutch that prevents you from further advancing your skills. It's important to work directly with the exploits so that you can start to develop a better understanding of how they work. The best way to do this in Kali Linux is by working in the exploit database. So to access it, change directory to user/share/exploitdb. Once there, you can use ls to list the contents of the directory, and then here within the platform subdirectory, you'll find a whole bunch of different scripts and also several other subdirectories that are unique to different platforms, and within those, a bunch more scripts that are specific to those platforms. So rather than trying to search through all of these different scripts and trying to find the one that you need that way, you can actually search through the files.csv file that has information about each of the different exploits within these subdirectories. So to do this, we can use the grep function. So let's say that I'm familiar with the particular service running on a foreign system that I want to exploit. I could use grep, then in this case, free sshd, and then the file that I want to perform the grep on, so files.csv. And here we get a list of each of the different exploits with that keyword in it. I can then further narrow my search by piping it over, and then using the grep function on the output of that result. And here we grep out just the remote exploits and eliminate the denial of service exploits that were listed there. So now we're down to only 2 exploits. And this second one in particular is the version that I need an exploit for. So I want to then browse to that directory. So change directory, then platforms, Windows, and remote. And then I'm going to copy that script to a different location with a name that I can actually better acknowledge what it is. So I'll change it to my root directory and then give it the name free sshd exploit. And then we'll change to our root directory. And there's our Perl script right there. So then we'll use the vim editor to view the script. And if we look through this, it's actually not that complicated what it does. Looks like it takes input from the user who executes the script on the host port, the user and password, and the target, which will either be XP Service Pack 2 or Windows Vista. And then after the buffer overflow, it's going to execute this shellcode, which if we browse to the bottom, based on the message it returns to the user, appears to be a shellcode that creates a TCP bind shell on the remote system on port 4444.
Now, a lot of these scripts are going to have to be tweaked because of certain things hard-coded in the script. In this case, that doesn't seem to be the case. So it seems like we should be able to launch the script just as is. So we'll execute the script once without any arguments to see the usage once again. And notice that it does prompt for a username and password. So this is a post-authentication script. So we're just going to assume that we brute forced access to the FTP service. We'll further discuss how to perform brute forcing network services in a later video. So then we'll launch the script with the arguments. So first with the host IP address, and then the port that the service is running on, and then the user is user, password is password, and then target is 1 for XP Service Pack 2. And once the script is done running, it tells you that you are now finished and that you can check your shell on port 4444. So then we'll go ahead and load up Netcat to connect to our remote shell that we've now created on that system. So we'll use nc-vn for verbose and then connect via IP address, specify the IP address of the remote machine, and then port 4444. And there you have it. We now have a shell on our remote system. So that is how to run an exploit directly from exploit code that you have pulled from the exploit database. The Social Engineering Toolkit is an entire penetration testing platform that is intended to take advantage of the weakest link in any organization's security, and that is its people. I don't have the time to demonstrate all of the different capabilities of the Social Engineering Toolkit, but if you browse through the menu, most of them are pretty self-explanatory. For now, I'll demonstrate how to use the credential harvester in order to gather credentials by using a fake website. So we'll start by selecting 1 for social engineering attacks. And then on the second menu, we'll choose option 2 for website attack vectors. Then choose option 3 for credential harvester attack method. And then we'll use option 3 for custom import. And then we want to enter the IP address of our backend listener. So this is going to be the IP address of your Kali system. And this is where we enter the path of the HTML file that we want to use. And as it indicates here, it has to be an index.html file. So we'll go to Iceweasel. And here you can download any website that you want that has a login option and perform this exact same attack. But because everybody's familiar with it, we'll go ahead and use Facebook for now. So we'll browse to the target website. And then once at the login screen, we'll use File and then Save Page As. Then I'll go ahead and save it in my root directory, and I'll create a folder for it called Facebook. And then, as indicated previously, use the file name of index.html. And then you want to be sure that you save it as a complete web page and not just the HTML file. And then you can close out your web browser, and then specify that path that you just saved it to. So we'll use root, Facebook, and then enter. And then we will use option 2 to copy the entire folder. And then here you want to enter the URL of the website that you're using. And now our harvester is now running on port 80 on our Kali system. So then what we want to do is perform a DNS poisoning attack against our target. So we'll switch over to our Meterpreter shell that we've acquired on the target system. Then what we want to do is alter the hosts file on that target system. This file will allow us to bypass DNS resolution. So change directory to Windows System32 drivers etc. and then list the contents. And there we have our host file. So we'll use edit hosts. Then in the VIM editor, we can enter as many poisoned entries as we like. So we'll use the IP address of our Kali system that is currently hosting our credential harvester. And then we'll have facebook.com resolved to that IP address. Then we'll save those changes and use the cat command to verify that the changes were made. And here at the bottom, we can see that they were. So then we return back to our harvester and wait for the user to interact with that website. So then if we switch over to the victim system and open up Internet Explorer, and we're going to simulate the user browsing to facebook.com. So they enter the address, facebook.com. And as you can see, the site looks almost exactly identical to the actual Facebook site. So they suspect nothing. So then the user on the victim system enters their email address and password. So naivevictim@yahoo.com. And then their password. Then whenever they click login, it will automatically redirect them to the actual facebook.com website so that no foul play is suspected. However, if we return back to our Kali system, we can see that we have now acquired both their email and associated password. So that's just one example of how you can use the social engineering toolkit in order to perform a social engineering attack. Burp Suite is a very powerful web application security assessment tool that is available in Kali. In this video, I'm going to demonstrate how to use Burp Suite to brute force access to a web application. So first we'll browse to our DBWA web app on our Metasploitable system. Then verify that the security is set to low, and then choose brute force over on the left side. Then we'll go ahead and go to our Kali Linux menu and then our top 10 security tools and Burp Suite. And once that's loaded, we'll go ahead and configure our proxy in Iceweasel. So go to Preferences, and then Advanced up at the top, and then the Network tab, and then click Settings, and then change from System Proxy Settings to Manual Proxy Configuration, and specify our proxy as our local system, so 127.0.0.1, and then at port 8080. Next, we want to verify in Burp Suite under the Proxy tab that Intercept is on. And then once we've done that, we'll go ahead and enter a common username in the login screen here, so admin, and then we'll enter just a random password, so I'll enter the word test, and then click login. And then if we move back over to our Burp Suite proxy, we'll see that it actually captured that GET request with the username that we entered here, admin, and then the password that we submitted, test. So then we want to click Action and then send this to Intruder. Once we've done that, click the Intruder tab, and then it already has pre-configured our host and port. And then under Positions, since we're only performing an attack on the password, we'll go ahead and clear the rest of these out. And then we'll select the value that was passed back for the password, so test, and then we'll add a payload position on that. Then move over to the Payloads tab, and under Payload Type, select Runtime File. Then enter the file path for our dictionary file. So user/share/ /wordlists/rocku.txt. Once that's done, select Intruder at the top and then click Start Attack. And it will then begin a dictionary attack with each of the different password options in that dictionary file. And what we're going to do is look for a unique response that differs from all of the other failed entries. So to do this, we can sort either by status or by length of response. As you can see, status is all the same, but if we sort by length, we have one that is different length than all of the others. So then let's expand this. And then right-click on the response and send to compare. Then select one of our baseline requests. And right-click on its response and also send it to the comparer. Then choose the Comparer tab at the top. And with one response selected in each item, click Compare by Words. And here you'll see highlighted the differences in the response. As you can see on the one on the right, which is our baseline response, we get username and/or password is incorrect. But for our one distinct response that we have here on the left, we get welcome to the password protected area admin. So this confirms that the password for the username admin is password. We can then verify that by removing the proxy configurations on Iceweasel. Then refreshing and entering those credentials. So admin and password. And there you have it. So that is how to brute force access to a vulnerable web application using Burp Suite. There are a number of commonly used attack vectors for web applications that you should be familiar with. We'll discuss each of these briefly. So begin by logging into your DVWA web application on your Metasploitable system, and then verify that the security is set to low. Then select SQL injection, and we'll go ahead and take a look at the source code. And by the source code, we can tell that what this application does is it sends this SQL query back to the backend database, and it queries the last name and first name for a user based on a provided user ID. So if we return to the web application, here you can see what it's supposed to do. When we enter an ID number, it provides us with a first name and last name. Then what we want to do is attempt to alter the output of the web application by modifying the query that's sent to the backend so that it provides a condition that's unconditionally true. This is called a tautological injection, and it's a commonly used SQL injection attack to bypass authentication or to gather information from the tables. So here, we'll enter a 1 and then close off the quotations, and or 0 equals 0. Because anything or 0 equals 0 is always true. And then because the quotations were already closed out, we want to comment out the quotations that are closed out and sent to the back. So we'll enter a £sign and then click Submit. And then that drops us every single username, both first name and last name and user ID that was in the database, because the condition is true for every single user. Next, we'll perform a cross-site scripting attack. So how this is supposed to work is a user enters a name and then a message, and then clicks Sign Guestbook. However, because of a vulnerability associated with this web application, we can actually execute scripts from it. To demonstrate this, we'll enter the name script, and then do a basic script that creates an alert. And then we'll pass that alert the
string XSS exploitation, and then we'll close out the script. Then when we click Sign Guestbook, it will actually execute that script. A commonly used cross-site scripting technique is defacement attacks using iframe injection. So we'll enter the name script2, and then we'll do iframe source equals, then we'll do the web address for Packed Publishing, and then close it out. Click Sign Guestbook. Here you'll notice that the first exploit we performed is also executed in sequence with our new script injection. This can be an effective way to string multiple scripts together. And then in our new post, we can see that the Packed Publishing website is now in our guestbook signature. Next, we'll work with unrestricted upload. Now, the intention of this web app is to allow us a place to upload different image files. However, because it does not screen the files that are uploaded, we can actually upload a malicious script here. So we'll click Upload. And then we can see that our file was uploaded successfully. Then select Command Execution. And this is meant to be just a ping utility where you enter an IP address and it performs a ping on that IP address and tells you if the host is live. The way this is supposed to work is you enter an IP address and then click Submit and it returns back the results. So we'll attempt to string this together with another command that will then follow it. So we'll use cat and then the location of the password file. And as you can see, we are now able to read the contents of that file. We can also execute the malicious script that we had previously uploaded. So we'll use Python and then specify the path of that script. And then malicious script.py. And then click Submit. And there you have it, malicious script executed successfully. So those are a number of different attacks that you can use to exploit vulnerabilities existing on a web application. Once you have successfully exploited a vulnerability on a target system and have acquired access, you should take measures to make sure that you do not lose access to that system if it's later patched or secured. One method for maintaining access is by creating backdoors into the system. Netcat is a utility that can be installed on a remote system and will function as a backdoor, providing remote terminal access to the system. In order to install Netcat on our target system, now that we've exploited it, we want to upload the Netcat executable to that system. So we'll use the upload command and then specify the location of the Netcat executable on our local system. So user share Windows binaries netcat.exe. And then specify the location that we want to upload it to on the target system. So C, Windows, and then System32. Now that it's uploaded, we want to create a registry key that will automatically boot up the Netcat service anytime the system is turned on, so that we have a permanent backdoor onto the system. To do this, use reg enum key -k, and then high key local machine, software, Microsoft, Windows current version, and run. And this will enumerate any keys that are currently listed that are processes that will start as soon as the system boots up. And there's currently no values within this registry key. So now we want to create one for netcat. So we'll use reg set val, then -k, then the same path, then -v to create a new value, and then we'll call this value netcat, and then -d to specify the data within that value. And we'll specify the location of the netcat executable to be executed, and then the switches that are used in it. So we'll create it as a listening port on port 6000, and then we'll execute command.exe. We can then verify the contents of that registry key with reg query val, then -k, and then that same path again, then -v and netcat. And here we can see that the changes were made to the registry. So then to test this out, we'll go ahead and reboot the target system. Once the system is rebooted, we can then attempt to connect to our backdoor using netcat. So we'll use netcat, then -v for verbose, and n to specify an IP address. And then we'll enter the IP address of our target system with the backdoor on it, and then port 6000. And there you have it, a remote shell on our target system. You can also access your backdoor using Metasploit. In order to do this, use the exploit multi-handler, and then set your payload to a Windows TCP bind shell. Then show options, and set your remote host to the IP address of the target system. And then set the local port to port 6000, the port that the listener is configured to, and then use exploit. And now we have access to our netcat backdoor using Metasploit. There actually is a post-exploitation script that you can run in Meterpreter in order to create a Meterpreter backdoor so that you can re-access your Meterpreter session at a later time, even if the system is patched. In order to do this, use the command run met-svc. What this does is it will install a Meterpreter service on the remote system, and then it will indicate what port that service is listening on. To reconnect to your Meterpreter backdoor, use the exploit multi-handler, then set your payload to Windows met-svc _bind_TCP. Then set your local port as indicated whenever you launch the script. In our case, it's 31337. And then set your remote host to the target IP address that's running the Meterpreter service, and then run the exploit. And there you have it, a Meterpreter shell that we can access via backdoor at a later time. So those are a few different examples of how you can install backdoors on a target system in order to maintain access after exploitation. EtterCap is a tool that will allow you to perform ARP-reply spoofing to perform man-in-the-middle attacks on a local area network. This will allow you to sniff traffic going between two target systems or a target system in the network gateway. To perform this demonstration, we need to get the MAC address of our local interface. To do this, open up a shell and use the command ifconfig eth0. Here where it says HW address, copy your MAC address, and then open up Wireshark. Once Wireshark opens, apply a filter for ICMP traffic and only traffic that's going to or from your local MAC address. So use eth.src == and then that address, or
eth.dst equals that address. So that will only return traffic that's ICMP traffic going to and from our local interface. Then select our interface and start sniffing. Once you're collecting traffic, switch over to your victim machine. Then open up command prompt. And from there, use ipconfig to identify your IP address of your target system and the local gateway. And then we want to perform a ping on the gateway IP address. And as you can see, we are receiving ping replies from the gateway. However, we're not currently picking up any traffic on Wireshark from our Kali system. This is to be expected as the traffic is currently being routed correctly. So what we want to do is use ettercap to try to get between this host and the gateway so that we can capture that ICMP traffic and anything else that travels between the two systems. So to open ettercap, use ettercap-G. Once up, select Sniff and Unified Sniffing, and then select your interface and click OK. Then click Host and Scan for Hosts, and this will scan the local area network. Once that's completed, select Hosts again and then Host List, and this will be the list of all hosts that were identified during that scan. So to begin our man-in-the-middle attack, we first want to select our target system, and then select Add to Target 1. And then we want to select the gateway address, and click Add to Target 2. Once that's done, select Man-in-the-Middle at the top and ARP Poisoning. And then click OK to start poisoning. Finally, once that's done, select Start and start sniffing. Now that we've performed our man-in-the-middle attack, we'll switch back to our victim machine. And then once again, we'll perform another ping to our gateway address. As you can see, we're still getting traffic back from the gateway. However, if you switch over to your Kali system, you'll see that that traffic is now being routed through our local interface. As you can see here, we have both ICMP echo requests from our target system to the gateway, and then echo replies from the gateway back to the target system. So that is how you can use ettercap in order to perform a man-in-the-middle attack. For this demonstration, we're going to assume that we performed a successful man-in-the-middle attack, and then by using custom filters, we were able to locate what appears to be password hashes within the captured traffic. Prior to attempting to crack a password hash, we want to determine two things. First, we want to determine the type of hash that we're working with, and then we want to make sure that the work hasn't already been done for us by referencing public hash repositories. The two tools that we're going to discuss to do this are Hash Identifier and Find My Hash. So the first tool that we'll discuss is Hash Identifier, which will use various signatures in order to attempt to classify a provided hash. In order to access this tool, use Hash Identifier command from any directory. And then all we have to do is enter the hash value here. So we'll enter a sample hash value. And then it returns possible hash types and prioritizes them by best guess. So the best guess on this hash value is a SHA-1 hash. You can also enter as many hash values as you want. So we'll enter one additional value. And in this case, this one was identified as an MD5 hash. Once you've entered all your hashes, you can use Control-C to close out the program. And once you've determined what type of hashes you're working with, you should attempt to determine if the plaintext values for those hashes are already available in online repositories. To do this, we'll use Find My Hash. So you can enter that command from any directory, and it'll show you the different uses and syntax of this tool. As you can see, all you have to do is execute the script with the algorithm that is used for that particular hash, and then any options that you want to include in the script. If you scroll down, you can see the different options include using -H for a single hash, -F to crack a file with multiple hashes, or if you can't locate the hash, then you can use -G to Google the hash value. So now we'll go ahead and run find my hash against our hash value. So we'll use find my hash and then SHA-1, as was previously indicated by hash identifier, then -H and the hash value. And almost immediately it locates the hash value in the first website referenced, and then returns us the plaintext value for that hash. We'll run the script once again against our second hash, so find my hash and then MD5, then -H and that hash value. This one does take a little bit longer, but then after referencing multiple sites, we do uncover the plaintext value for this hash. So that is how to use hash identifier and find my hash to both identify what type of hash you're working with, and then determine if the plaintext value is anywhere available on online repositories. Assuming this isn't successful, we would then move on to password cracking. Now we're going to talk about how to perform online password attacks against live network services using Hydra. If we enter Hydra at the command line, you can see the various uses and syntax of this tool. And as you can see, there's a lot of different options for attack configuration here. In addition to that, if you scroll down towards the bottom, you'll see a list of all of the different supported protocols. These are all of the different services that you could potentially run a Hydra attack against. And then at the bottom, you'll see some examples of different commands that could be used. So for our demonstration, we are going to perform a password attack against the FTP service running on port 21 on our Windows system here. So I'll use the ls command to list the contents of my current directory, and here I've created a text file of some commonly used FTP usernames. My plan is to use this text file in combination with the rocku.txt password dictionary file in Kali in order to perform a comprehensive password attack against this FTP service. So to do this, we'll use the command Hydra, then capital L, and then the file name for our username text file, then capital P, and then the location of our rocku.txt dictionary file, then the IP address of our target system, and then the service that we want to attack, so in this case FTP. Immediately this will return information about the attack to include the number of concurrent tasks that are going to be performed, in this case 16, and then also the number of attempts that are going to be required in order to complete the entire attack. In this case, we're looking at 71,721,995 attempts. Hydra will also periodically report back information about the progress of the attack. Here we can see that at the 1 minute mark, we are performing 461 attempts per minute. It'll also indicate an estimated amount of time that will be required to complete the attack based on this rate of attack. Finally, after some time has passed, we have managed to break one of our FTP user accounts after approximately 7 minutes and 3,420 attempts. You can also perform a traditional brute force attack in Hydra that will attempt every possible password combination within a specified parameter. To see more information on how to do this, enter the command hydra-x-h. And this will clarify how to configure your brute force attack with minimum, maximum, and character set values. So to perform our brute force attack against our FTP service, we'll use the command Hydra, then lowercase l, and then the specific account that we want to perform the attack against, in this case root, and then -x to specify our brute force attack, and then our minimum value of 4, maximum value of 6, and a lowercase a to indicate lowercase alphabetic characters only, and then our target IP address, and then the service that we want to perform the attack against. And because of the simplicity of this password, this one is quickly returned with a login ID of root and a password of able. So that's how to perform both a dictionary attack and a brute force attack on live network services using Hydra. Now we'll use a interpreter shell in Metasploit to drop the local password hashes for both our Windows and Linux target systems. Then I'll demonstrate how to crack them with offline password attacks using John the Ripper. So first we'll start with our Windows system that we've already acquired an interpreter shell on. To dump our password hashes, use the command run post/windows/gather/hashdump. After it drops those password hashes, we want to copy them and then place them into a text file. So we'll open up a separate shell and then use the vim editor to create a winhash.txt file. Then we'll paste the hashes into that file and then save it. And then use ls to verify that it is on our root directory. And then we can use the cat command to verify the contents of the file. Now we want to do the same thing for our Linux system, which we've also acquired an interpreter shell on. To drop the hashes for this system, use the command run post/linux/gather/hashdump. And that will also drop the hashes for each of the user accounts on the system. However, with this script, it'll actually automatically load those hashes to a file on your local system. So we'll go ahead and browse to that file. So we'll change directory to root.msf4/loot, and then ls to list the contents. And the one that we want to copy is the hashes file. So we'll use cp to copy the file, then specify the file name, and then the location that we want to copy it to. So we'll copy it to our root directory, and then give it the name linuxhash.txt. Then we'll change back to our root directory, and then with ls you can see that we now have both a Linux and Windows hash file. Now that we have hash files for both of our target systems, we can use John the Ripper to perform offline password attacks against these files. If we use just the John command at any directory, we can see the different uses of the tool. So to perform a basic attack against our Linux hash file, we'll use John, then -- format, and set it equal to MD5. And then specify the hash file. And almost immediately it starts cracking those passwords for the user accounts. You can see the passwords on the left side and the associated user accounts on the right side. By default, John will use a combination of different password attacks against a file, but we can use specific attacks as well. In this case, against our Windows system, we'll use John and then format and lm. And then to use a dictionary attack, we'll use word list and set it equal to our rocku.txt file. And then we'll specify the name of our hash file that we want to perform the attack against. And once again, we can see our passwords cracked on the left side and our user accounts that were associated with them on the right side. So that is how to use John the Ripper to crack local passwords for both Windows and Linux systems. There are also graphical interfaces for both Hydra and John the Ripper. These tools are called X-Hydra and Johnny. To demonstrate how to use these, I will perform the exact same attacks as in the previous videos, but this time using the graphical interfaces. So to open up the graphical interface for John the Ripper, open up a shell and enter the command Johnny. And this one is extremely straightforward. Just use open password file, then specify the password file that you want to perform the attack against. And then it lists everything out in a series of columns. You've got a user column, an empty password column, a column for your hash values, and then Gecko's user information column. So then click Start Attack, and it will start populating the values in your password column for each of the different user accounts. To switch to a different file, click Pause Attack, and then open password file. And now we'll do our winhash.txt file. And once again, Start Attack. Once again, it starts populating our password values for each of the different user accounts. To access the graphic user interface for Hydra, enter X-Hydra at the command line. And we'll specify our single target IP address. And then the port for the service that we're attacking, so port 21. And then the service that we're performing the attack against, so we'll specify FTP. Notice how at the bottom of the screen it actually begins to generate the command that's going to be sent to the back end. So this can actually be a helpful tool in learning how to use Hydra. So for our username, we'll select our username list, and we'll use our FTP usernames.txt file. Then for passwords, we'll use the password list. We'll browse our file system to the user directory. Then share. Then word lists. And then our rocku.txt file. Under tuning, we can do different performance configurations, such as the number of simultaneous tasks and the amount of time required for an attempt to timeout. We can also do proxy configurations. Under specific, we've got some more advanced configurations. And then when we click the Start tab, we can see the output of the tool here. So then click Start at the bottom. And then this will provide us the exact same output that we got when we used the tool in the command line. And then it completes the attack and returns to us the username and password to access our FTP service on that remote host. So that is how to use the graphical interfaces for both Hydra and John the Ripper to perform both online and offline password attacks.